Welcome to Engineer Campus, a place where I help you to bring your idea into a product. And today we will talk about engineering drawings to share ideas. You develop your complete product, and engineer drawings are now the first step to actually document your work so that you can share it. The Manual of Engineering Drawings for Students and Draftsmen has expressed it really well what engineer drawings are, and I'll just read the text here. Engineering drawings are used to fully and clearly define requirements for engineering items. More than merely a picture, it is also a graphical language that communicates ideas and information from one mind to another. Most especially, it communicates all needed information from the engineer who designed the part to the worker who will make it. So engineer drawings are an important part in this transfer of information. The fundamentals of an engineering drawings are here. We have the geometry, the object itself in different views, as it is necessary to know the form. We have the dimensions, lengths and angles, mostly in millimeters and degree. We have the tolerances of the dimensions shown, the allowable variation. We know the material of the object in proper terminology, so not just it's a steel or wood or something, but with proper steel grade and classification. And we know the finish, the surface quality, special treatments, and which are important for manufacturing to estimate care to detail, time and cost. If you have to add an additional treatment step, it will take longer to produce, will be more expensive, and the producer needs to know this. So how do you get to your technical drawings, to your engineering drawings? Well, first you need to know what to draw. You have to know if it's the complete product, just a part, or a group that you draw. So here we have the complete product, which consists out of one part, a C, a component or a group, G, and the groups themselves are also consisting out of components or even in groups here. So you have to draw each component, each group, and the complete product to get a complete set of engineering drawings. Next, you decide what kind of perspective you have to draw. This depends on what kind of product you have. Important is that you don't have redundancy, but you still show every aspect that is needed for clearly knowing what the product will look like. Third, you choose the paper dimensions. For simple parts it can be smaller paper, or for complete product drawings you will choose a bigger paper, also totally dependent. And you are allowed to scale your product. You don't have to draw one-to-one scale all the time. After doing this, it's time to draw it. You draw the object with fine lines so that errors can be fixed easy. You add cuts that view hidden contours that make it easier to see everything in the product, if necessary, of course. You draw patterns on cuts and special surfaces. And then you retrace all lines in the right thickness and line type. For example, you need a bigger contour, a bigger line type to trace the contours of the product. After doing this, you add the measurements. Here are also different techniques. For example, on the left we have measurements that are stacked on themselves. So you have to also stack then the tolerances. Whereas in the right, all tolerances, all measurements are related on just one point on the product, from which on it's then measured. After this, you add surfaces and tolerances, where you can give a lot of information. Of course, here it's also as much as necessary, as few as possible, and it's important to, again, no redundancy and give all the information that is necessary. After this, step 7, you fill out the information in the title block with the part name, of course, with a person which is responsible for it, and with all the additional information with tolerances, part number, drawing number, which pages is, and material treatments and address of the company, maybe, all relying on what kind of product you have and what kind of company you're drawing for. And last but not least, finally, there's also a guide on how to fold your drawing, and then you can put it to the other documents that you probably produced and have it all in one place. So technical drawings connect engineers and manufacturers with its own language. Learning the skill, like any other, needs a lot of practice and care, and thus adds high value of the work of an engineer. The result makes the ideas, planning and calculation design accessible to others. CAD further expands its options by reducing costs and delivering a virtual object which can be used for testing and presentation and programming of the machines in manufacturing. So after doing this, there's only one step left, and I hope I see you then. Thank you very much.